Thousands of people die due to traffic congestion. The ambulance would get stuck in traffic rather than reaching its destination in time to save the patient. Many emergency cases require immediate medical attention, and any delay could be fatal. So, to give these patients a fighting chance, traffic lights should be designed to handle these cases and provide a swift, uninterrupted access to the roads. This doesn't only apply to ambulances. Fire engines need to arrive at the scene of a fire quickly to be most effective and avert unnecessary collateral damage. Police vehicles would also need to be considered as priority vehicles. We attempted to solve this problem by proposing a smart traffic light system that doesn't only provide flow control but also gives priority to emergency vehicles. The circuit can be broken down into three parts: inputs, central processing unit, and outputs. Our inputs include an RFID reader and an ultrasonic sensor. The outputs are the control signals sent to the traffic control system. The RFID module was created by Yusuf Ashraf and Mark Ragai. The CPU unit was created by Mohammad Qabil and Karim Negi. The ultrasonic sensor module was created by Andrea Medhat and Mark Mohib.
Ultrasonic sensor. Ultrasonic sensors use ultrasonic waves to determine the distance to the nearest object. We use two ultrasonic sensors in each lane, and that is to overcome any blind spots and to consider the nearest chord to the sensor. The ultrasonic sensors were set up at fixed points at the far end of each lane, so the less distance it detects, the more traffic there is. An ultrasonic sensor has an emitter and a receiver. The time it takes for the emitted sound to return back is used to calculate the distance. The sensor has 4 pins, 2 supply pins, 1 input pin, and 1 output pin. The output pin from the board to the sensor is the trigger pin, which acts like an enable. Once you give it a pulse, it initializes the sensor and it starts to take readings. The echo pin is considered to be the input to the board. Unfortunately, the sensor doesn't provide distance as an input, but rather time taken for the sound signal to return. By using the equation 2 times distance equals speed times time, the distance can be determined.
Commonly see RFIDs in the form of keys, whether to open garage doors or active elevators. Each RFID tag has a unique serial number that the RFID reader tries to match to the serial number it has stored, whether to allow or deny access to the person carrying the RFID tag. We don't need to go into the depths of serial number reading and matching, as only emergency vehicles are equipped with RFID tags, although in real-life application, each type of the emergency vehicle should have a unique serial number that's stored in the central processing unit to prevent people taking advantage of the emergency traffic service for their own.
The principle of operation of RFID systems depend on communication through UART, which is a form of serial communication between the reader and the tag. In UART, bits are transmitted sequentially over a wire at the rate of 9,600 bits per second, which is called the baud rate. Other baud rates exist, however this is the most common. Each data byte is preceded by the logical 0 bit to indicate the beginning, and it is succeeded by a logical 1 bit to indicate the end of the byte. In this model, we only need to detect that some data is received, indicating the presence of an emergency vehicle.
The Central Processing Unit, or CPU, is the brain of the whole operation. The CPU is designed to make sense of the inputs it receives from the ultrasonic and RFID sensors. The CPU houses the project's control unit, sending the control signals. Regarding the ultrasonic sensors, there are 2 in each lane, which the CPU compares the signals from and chooses the minimum of the 2 to avoid issues that may arise from blind spots. According to the signal, the traffic timer of the lane is given one of 3 main values: a maximum time and a default time, a minimum time. These different time settings will allow the system and the CPU to better handle most situations that may arise due to different amounts of traffic in the lane.
As for the RFID reader assigned to the lane, the CPU uses its signal to determine whether or not it will interrupt the lane's timer, based on the fact that a signal 1 from the reader means that an emergency vehicle was registered in the lane. Otherwise, the timer will be determined by the original time assigned to each lane and the US. Furthermore, the CPU provides the control signals that will determine the outputs to the traffic lanes.
Now we will see a simulation to the traffic control system in action.